Okay, it's Jacob again, and we'll be picking up right where we left off, talking about equilibrium, shortages, and surpluses in the context of supply and demand shocks. So, we've seen how if you change the price, an equilibrium was defined as being a situation where the quantity supplied and quantity demanded equal each other, where these two curves intersect. We talked about how, or to lower the price, it would result in a shortage. People would be unable to buy as much as they want to buy. And if you were to raise the price, it would result in a surplus. Producers are unable to sell as much as they want to sell. And both of these problems are self-fixing, because voluntary trade enables people to adjust the price in the direction of equilibrium, raising the quantity. But what happens when shocks happen? What happens if one of the curves were to move? Well, that's what we'll look at now. So let's talk about brandy, distilled wine. And brandy used to be a very ritzy drink, or rizzy if you prefer. It was associated with European aristocrats, nobility. It was associated with robber barons of the Gilded Age. And it was also associated with Southern plantation owners. Here you see Scarlett O'Hara from Gone with the Wind became a raging alcoholic. It was very much an old man's drink. And then, for some reason, rappers decided they liked it. I don't know why, don't know how it came to be, but it became a big deal in the hip hop scene. And they call it drinking Henny. So, what would we expect to happen to the market for brandy? Well, because the rappers have decided they like it now, and because people tend to be trend followers, right? Their fans would consider brandy a more prestigious drink now. We would expect that people who are into the hip hop club scene's marginal willingness to pay would go up. Or, sorry, that should have said maximum. Their maximum willingness to pay would go up. Their marginal benefit would go up. And what did we call that situation where your marginal benefits increase? We call that a positive demand shock. And what you'll find is that when the demand increases, it now intersects the supply at a new equilibrium with a higher price and quantity. And then that price is going to be, the current price will be lower than the new equilibrium. And so that puts the market into a shortage. And then the shortage resolves itself as the market equilibrates. So here you've got your graph demonstrating that. You've got supply and demand of brandy. The red curve is your old demand, and the yellow curve is your new demand. Now, your rappers, they start drinking it. They start including it in their music videos. They start advertising for these products. And the consumer decides that they want the product more. They're willing to pay more for it because they value it more than they used to. And the demand curve increases. And there's really two different ways you could look at it. You could either look at it on the price side and say that at every quantity, they're willing to pay a certain amount more. Or you could look at it from a quantity point of view and say that at every price, they want to buy a certain amount more. But these are just the same concept expressed two different ways. Now, notice how the curve, it moves. You might think of it as moving up. You might think of it as moving to the side. Really, it's doing both. The curve moves, but it slides along the supply curve as it moves. And since it's moving up and to the right, this means that the equilibrium price increases and the equilibrium quantity increases. Now, notably, it does not go up by the full amount of the marginal benefit. That's one thing I want to emphasize. And this will become important when we talk about taxes and subsidies in Unit 2. See, even though consumers are willing to pay a certain amount more, let's say $3 a bottle, the equilibrium price does not wind up being $3 more. It might be more like $2 more or $2.25 more. It doesn't go up by the full amount because that supply is capable of expanding. Producers, in response to the price hike, begin to produce more of the product, but that means there's more of the product to compete with itself. And so that makes the bidding, the competition more intense, and that's going to cut back into that price increase. And how does the market get to the new equilibrium? Well, the moment that demand shock happens, you were at your old equilibrium. But when demand goes up, suddenly your old equilibrium is not your equilibrium anymore. At the old lower price, quantity demanded is now a lot higher, and quantity supplied a lot lower. And we have a term for that, don't we? We just talked about it. Shortage. So the market is thrown into shortage, but then the shortage resolves itself as the price steadily rises. Through the bidding of the consumer and through the producer's increasing output. Now, if it were a negative demand shock, everything would work in reverse. And you can see that here quite simply just by flipping the colors on it. If we were starting out at the high price and then the demand fell, the new equilibrium would be at a lower price and a lower quantity. For example, the rappers might learn that brandy was the favorite drink of Scarlett O'Hara, and then they decide that it's lame, right? That's like an old racist grandmother movie from the 30s. It's not cool anymore. So they their demand falls. The market, because the demand fell, because the equilibrium moved, you are immediately thrown into a pardon me, a little mistake. You are immediately thrown into a surplus situation because now The consumer, since they don't desire the product as much, the consumer is only going to buy this amount, but the producer at the old price, they're still willing to make the same amount. And you get unsold goods. The brandy sits on the shelves. But that surplus resolves itself. The market equilibrates, the market responds. Because those producers don't want to be stuck with the unsold goods. And so they lower their prices and they lower their output. And that surplus falls and falls and falls until we wind up back at equilibrium. This is what positive demand shocks are going to do. A positive demand shock is going to throw you into a state of shortage. A negative demand shock is going to throw you into a state of surplus. But the shortage and the surplus are only going to be temporary because the market equilibrates. And in the end, your quantity is going to increase and your price is going to increase if it's positive, and your quantity is going to decrease and your price is going to decrease if it's negative. And you can see that here on the document camera. Now, what about with supply? How would a supply shock impact this? Well, drawing from other recent news, there is a problem right now in the Red Sea. See, ever since the most recent bout of Arab-Israeli war broke out, a group of Yemeni militants called Houthis have been shooting at any shipping that passes through the area. In theory, they're shooting at Israeli shipping, but in practice, many ships are like, you'll have a ship where the captain's from Norway, the crew are from Bangladesh, the ship itself is registered in Panama, and then there's like 12 different countries that all own a share in it. So, you know, pretty much all of this stuff is in some way tied to Israel. So in practice, the Houthis, they're shooting at everything that passes by. And this presents a bit of a problem because a very, very large amount of trade passes through the Red Sea. Now, suppose that you're a European and you're buying cheap gewgaws from China. What would you expect to happen to the gewgaws market? Well, if you have to go around the Cape of Good Hope, that's going to require way more extra shipping. So the whole point of the Suez Canal and of the Red Sea was that it enabled Europeans to cut out this long, unnecessary, dangerous trip. You see how the Mediterranean route is much shorter. And time translates into additional costs. If it takes you longer to get somewhere, you're going to burn more fuel getting there. You're going to be paying more wages to get there. And you're also going to be doing more ship maintenance to get there. Yet you're still delivering the same size load. You still have the same cargo capacity on that ship. This would be most similar to the technology problem we talked about in the supply video. It's like technology has gone down. You have to have more inputs. You have to spend more on inputs just to get the same amount of output. And so we could classify this as a negative supply shock. Now, what happens with a negative supply shock? Well, in a negative supply shock, the opportunity cost increases. And much like with the demand shocks, we can look at it based on either the price or the quantity. We could say that at every quantity, you have to have a higher price in order to be willing to make it. That opportunity cost was the greatest, or that opportunity cost, you have to make at least that much in order to be willing to produce that many units, right? So if your costs go up, you would have to raise prices by the same amount if you were to keep the same quantity. On the other hand, we could look at it from a quantity point of view, and we could say that at the same price, you would reduce your quantity. Either way, it has the overall effect of raising prices, lowering quantity, and thus moving the curve up and to the left. Whereas with demand, it moved it up and to the right. Now, like with the demand curve and the demand shock, this supply shock is going to make the supply move along the demand curve, and wherever it settles will be the new equilibrium. And in this case, that new equilibrium has a higher price and a lower quantity. Two, three. So the equilibrium has moved. The quantity demanded stays the same because the consumer's preferences didn't change, but the quantity supplied fell because at the new supply, they're not willing to make as much at that price. And so the market is thrown into a shortage situation. But as we know, shortages resolve themselves. Markets equilibrate. And so, just like with the positive demand shock, the price is going to begin to rise. As it does, the quantity supplied goes up, the quantity demanded goes down, and the quantity traded increases until you get to the new equilibrium level. If it were a positive supply shock, it would all be reversed. With a positive supply shock, the cost of production falls. It's cheaper to make the good. It's more attractive to make the good. And so at the same price, producers would want to produce more. At the same quantity, they would be willing to accept a lower price to make the same amount. They don't want a lower price, but they would tolerate a lower price. Which means that the supply curve shifts down and to the right, intersecting the demand curve at a new point, which has a lower price and a higher quantity. And the market would be thrown into a state of surplus. So remember, increasing demand or supply always means increasing the quantity. And this means positive shocks increase quantity. But the two different kinds of shock are going to have very different effects on the price. A positive demand shock is going to increase the price. People value the good more, and so they bid it up. Whereas a positive supply shock is going to decrease the price. They're able to offer more of it for the same prices, and so they glut the market with the product. And a negative shock will just do the opposite of whatever a positive shock does. So really, you can simplify this down, even though there's 4 different types of shocks, and you have to know the effects on price and quantity of all of them, you can really simplify it down to just a handful of rules. Positive increases quantity, positive demand increases price, positive supply decreases price, and then negative does the opposite of positive. Now, what if we want to do two shocks at once? Well, we can combine these facts to make predictions about when both supply and demand have a shock. And what it comes down to is that supply and demand move. Corrected a little mistake on it. Supply and demand move together in quantity, but they move against each other in price. So if I have two positive shocks at the same time, demand and supply, I know that they both increase quantity, and so quantity is going to have to go up. As we see here and here, right? If I had two negative shocks, they both decrease quantity, and so I know that quantity is going to go down. However, supply and demand shocks have opposite effects on prices, right? So if demand is going up, that would raise the price. But if supply is going up, that would lower the price. So we have two forces that are fighting each other. Now, one of them is going to win out. But unless we actually have data, unless we can actually observe it, we can't necessarily say which one is going to win out. And so I say that the price effect will be unknown. Similarly, if demand falls, that lowers the price, but if supply falls, that raises the price. And here, the price effect is unknown. Now, what about the cases where demand and supply are moving in opposite directions of each other? Well, they're a little harder to memorize, but if they're moving at odds with each other, that means that their effects on the quantity are at odds with each other, making that unknown. But you will be able to say for sure what happens to the price. If demand is going up yet supply is falling, it costs more to make the good, but people also want the good more, then of course the price is going to have to increase. And likewise, if demand is falling and supply is increasing, producers can sell it for cheaper and people aren't willing to pay as much, then the price is going to have to decrease. Now we can use this to make predictions. So I've got a kind of complicated scenario here. A gang robs the Canadian maple syrup reserve, reducing syrup supply. Meanwhile, the bee rustlers of Ireland force bee ranchers to start hiring extra security. Question: what can we predict will happen to the price and quantity of honey? I recommend pausing the video, and I'll count you back in. 1, 2, 3. Okay, well, this might seem like a complex problem. It has several parts to it, but the key is to boil it down to specific relationships. Now, the first thing we'll want to identify is what specific things have happened. And there are two things that have happened. The maple syrup reserve got robbed, and the bee rustlers of Ireland became a problem. Now, what would be the relationship of maple syrup to honey? Well, they're both, I was going to call them condiments. Honestly, I don't know if that's an accurate way of describing them. They're both sweet things that we put on food to sweeten them. Honey on bread, syrup on on pancakes. I think that more than anything, they sound like compliments, don't they? So the relationship is probably that of compliments. And it says that the syrup supply was reduced. Well, what happens when supply falls? We know that or put this another way, what is the relationship of a compliment to another compliment? Well, it's through their price. That when the price goes up, the demand falls. Now, reducing the supply of syrup would drive the price of Mayday, Mayday, 1, 2, 3. Okay, so let's tackle this. Now, when you have a multi-step problem, the way that you would approach it is you want to identify all of the facts in isolation and then see if you can categorize them in some sort of systematic way. So in this scenario, there are essentially two different things that have happened, two different things that could be a shock. There was the reduction in the syrup supply, and there was the hiring of extra security. Now, what is the relationship of syrup to honey? Now, with a lot of these, you can come up with any answer in the world. But I think most people would probably consider syrup and honey to be substitutes to each other more than anything. If they don't have a particular relationship, then they're more than likely substitutes. And they're both sweet. I don't know if you can quite call them condiments, but they're both sweet, goopy foods that you spread on bread. Honey on bread, syrup on pancakes. So I think it's fair to say that these are substitutes. Now, what is the relationship of substitutes to each other? Well, it revolves around what happens to their price. So, when supply of a good falls, that drives the price up, which means that we're talking about an increase in the price of a substitute, which would increase demand. Boom. Now we know we're talking about this half of the square. Now, what about the rustlers? Well, when you have a situation where it takes more inputs to produce the same amount of output, in this case, security is the input, we would call that a reduction in technology, right? And that would reduce supply. And thus, we can narrow it down to this. Because of the Canadian Maple Syrup Reserve robbery and the bee rustling problem, we would expect the price of honey to go up, but we would have to know more if we were to say what's going to happen to the quantity. It's a goofy problem, but it's inspired by real life. There really was a Canadian strategic maple syrup reserve heist, and there really are bee rustlers in Ireland. NPR is a wonderful thing. It's got its problems, but I every now and then I turn it on because that's the only place where I'm going to hear about crap like that. Now, one last question. How often are we in equilibrium? And the short answer is we're basically never there. See, supply and demand shocks are constantly happening. And as soon as a shock occurs, a shortage or surplus happens, and the market has to catch up. But the market is always trying to get back to equilibrium. I'm going to revive my gravity metaphor here again. See, You might imagine the market as being like a bucket of water hanging in the wind. As the wind pushes the bucket one way, water is going to slosh to one side. And then if the bucket were to be pushed in the other direction, the water would slosh the other way. In a very turbulent wind, the water is constantly sloshing around. It's constantly moving. But the movement is not chaotic. The movement is not meaningless. It has a goal. It's always trying to level out because gravity is pulling on it. In real life, supply and demand shocks occur constantly. They can even occur continuously. Throughout this class, we almost always talk about time as though it's discrete, but in reality, these curves, you might think of them as actually shifting around smoothly. But despite that, the market is always moving in the direction of maximum efficiency. It may not be efficient because the world changes too quickly, but it is always repairing itself. It's always chasing after that goal. Now, in conclusion, a competitive equilibrium is the price where quantity supplied and quantity demanded are equal. If you have a free competitive market, any price lower will cause a shortage and any price higher will cause a surplus. Self-interested behavior by consumers and producers resolves the shortage or surplus and maximizes quantity traded. We can predict the effect of one shock on price and quantity traded. We can predict the effect of two shocks on price or quantity traded. Depending on the combination of what types of shocks it was, it'll be one or the other, never both. And competitive equilibrium is efficient and stable as nobody wants to buy more or less at a price that someone else would accept. So, in our next video, we'll finish up Unit 1 by talking about how we measure the welfare gains of trade. We'll see how competitive equilibrium maximizes welfare, and then we'll use this method to analyze the effects of various policies, like price controls, taxes, and subsidies, as well as to find the situations where markets are actually suboptimal, where perversions in the incentive structure of society cause a market to fail, to not find its most optimal level of output.